Hello, my name is Dr. Linda McIver and I run the Australian Data Science Education Institute. We're a charity dedicated to helping kids understand data. Today's topic is correlation versus causation. Correlation versus causation is the puzzle of whether things being correlated or changing in sync with each other means they're causal, i.e. one causes the other. Correlation happens when two different variables go up at the same time. So for example, as people get taller, they tend to have larger feet. So height goes up at a similar rate to shoe size. This is good because I am 185 centimeters tall, and if my feet weren't large, I'd probably fall over way more than I actually do. In another clear example of correlation actually being causation, as soon as my video on exponential growth and COVID-19 came out, the Australian government put much stronger measures in place to try to minimise spread. Obviously, that was entirely down to my video because it came right after it. Yes? Our brains are naturally optimized to treat correlation as causation because it turns out it's a pretty useful assumption a lot of the time. If eating something, say shellfish or nuts, or in my case, silver beet, true story, makes you really ill, you're going to want to not eat it a second time. Correlation, in this case feeling sick right after eating nuts, implies causation, i.e. it was the nuts that made you sick. One time I ate a lot of lemon shortbread right before I got gastro, and I haven't been able to bear the thought of eating biscuits like that since. It's a useful survival trait, but sometimes it misleads us. You might almost say that correlation and causation are correlated, but only if you wanted to use a very lame nerd joke and cause your children to mock you. So I want to show you a website called Spurious Correlations, which has a wonderful collection of correlations which are not causative at all. It's great fun to play with and a really good example. So we're going to switch over to screen sharing. Okay, so this is the Spurious Correlations website. It's a wonderful sequence of graphs that shows a whole bunch of things that are correlated, but obviously not causative. For example, the number of people who drowned by falling into a pool correlates really nicely with films Nicolas Cage appeared in. Per capita cheese consumption correlates with the number of people who died by becoming tangled in their bed sheets, which is a disturbingly large number. Divorce rate in Maine correlates with per capita consumption of margarine. You can go through this website in great detail and it's a lot of fun. Just to make sure you actually understand correlation properly, here is my little chart of height versus shoe size. These are rough approximations of people I know and their shoe sizes, mostly people in my family. And one of the things that's worth pointing out is that correlation doesn't mean equality. So just because two things are correlated doesn't mean that you can accurately predict one value based on the other. So here we have three people who have a shoe size of 10, and yet they have quite different heights. One is 190, one's 180 centimeters, and one's 169. And if you graph these, you will see that correlation isn't a nice, neat, straight line anywhere outside of a textbook. Let's insert the chart. Right, so this is not a nice, neat, straight line, but you can see it does have an upward trend. So correlation doesn't give you any particular value, but it does tell you that things are likely to go up in sync with each other. So as people get taller, they mostly have larger feet, but sometimes you have short people with large feet and tall people with small feet. It's a thing. Okay, so what does all this have to do with coronavirus? Well, let's go back and have a look at the total number of confirmed cases. Remembering that confirmed cases are simply the people who've been tested and found to have the disease, not the total number of people with the disease in the country. We don't know those numbers. And if we scroll down here, we look at total number of confirmed cases. Okay, the latest update as of yesterday is that Australia is doubling in 4 days, which is better than 3 days, but still pretty bad. We had 77 new cases confirmed overnight. Now, why do I care about correlation versus causation in the context of COVID-19? The reason is that we're hearing a lot of very dodgy claims about what is happening with COVID-19, and we don't really have enough information yet. So for example, one of the things that's being said is that hot countries are going to be okay. There is very little corona threat in those. And the two of the examples that are being used to highlight this are Indonesia and Singapore. So let's find Singapore. which is indeed handling the situation very well. Their cases are only doubling in 11 days, which is much, much better than the 4 that Australia is currently looking at. But they only have 243 cases in total. So that's really good. They've controlled their outbreak, and it's been going for some time now. Now let's look at Indonesia. Also, they're doubling in 3 days, which is bad, but they also have a very low number of cases. They've only got 172. So, okay, hot countries, looking good. Egypt, only 166, still looking good. We could actually find a lot of data here that suggests that heat is helpful. The thing is, we don't actually know yet. And what is missing from this attempt to prove correlation is all of the other data. And that's often the case. When people use correlation versus causation, they miss out a lot of the details. So the details in the case of Singapore, for example, are that they are doing a massive amount of testing. And they have done extremely effective social distancing measures, and their population actually adheres to the social distancing guidelines, and when they're told to go home and quarantine, they actually do go home and quarantine. They don't go to the supermarket on the way, and they don't have a prime minister saying it's all okay, we can go to the rugby. So Singapore is doing all of the right things and has a low number of cases. They also happen to be a reasonably hot country. So what of the features of this case are helping the total remain low? We still don't know. It's early days yet. Indonesia, on the other hand, has a low number of, wait for it, confirmed cases. They have also done an extraordinarily low amount of testing, somewhere around the region of 1,000 tests, right? So Indonesia actually doesn't know how many people they have who are currently infected with coronavirus. They don't know. So we can't use Indonesia as a data point to say hot countries are fine, because we have no idea what situation Indonesia is actually in. So there's a lot of other misinformation happening about coronavirus, and that's pretty normal when it comes to health. I'm sure you've heard people say, the one time I got the flu shot, I got the flu right afterwards, so the flu shot can actually give you the flu. Medically, we know that the flu vaccine can't give you the flu because the virus in that vaccine is inactivated. It can trick your body into producing antibodies, but it can't actually give you the flu. But because the virus they did get, which may have been a strain of the flu not covered by the vaccine or a different virus entirely, happened so soon after they got the vaccine, the correlation must be causation survival trick kicks in and makes a potentially very dangerous connection. The thing is, data is really good at telling you what is going on. It's not so good at telling you why. So the next time someone tells you two things are correlated and it's obvious that one causes the other, you can say, but wait, correlation isn't causation. We need more information. This has been another Data Science Explainer from the Australian Data Science Education Institute. Like it, share it, do all that good stuff. And you can contact adsei on the adsei website, adsei.org. You can email us, you can find us on Twitter, and you can donate at givenow.com.au/adsei. Special shout out to my friends at the San Diego Supercomputing Center for this awesome t-shirt which says, I do data science, what's your superpower? Learn our superpowers by continuing to watch these adsei videos. See you next time.